Today we are doing lesson 6-4, properties of rhombuses, rectangles, and squares. A rhombus is a parallelogram with 4 congruent sides. Notice the markings on the shape. List all properties of a rhombus. Well, we know a rhombus is a parallelogram, so anything that works for a parallelogram will also work for a rhombus. So I would write these things down. Opposite sides are equal. Opposite angles are equal. One pair of sides equal end parallel. Diagonals bisect. And both sets of opposite sides are parallel. Please pause the video if you need more time to write. A rectangle is a parallelogram with 4 right angles. So here's what your diagram may look like. 4 right angles. So because it's a parallelogram, all the things that are true about parallelograms will also be true for rectangles. So what I'm going to tell you is to write down the same things that we had for a rhombus. Or you could just write down see slide 1, see previous slide. A square is a parallelogram with 4 congruent sides and 4 right angles. So the two new stipulations are it has to have 4 right angles and 4 congruent sides. And also, all the things for a parallelogram have to be true. So let's practice. It says, decide whether the parallelogram is a rhombus, a rectangle, or a square. Explain. Number 1, what I see with my picture is that all 4 sides are the same. So I'm thinking it's either a rhombus or it's a square. The only thing I see are sides, so I'm going to call it a rhombus. Number 2, I see 4 right angles, and I see opposite sides are the same. This is called a rectangle. Number 3, I see all 4 sides the same, and all 4 angles the same, and the angles are 90 degrees, so I'm going to call it a square. Number 4, I see 1 pair of parallel sides, and I see opposite sides equal. So if we think in terms of parallel lines and a transversal, what's going to happen is same side interior angles have to be supplementary, so this one would also have to be 90. And we can also say that these would have to be 90. So I would say we are working with a rectangle. So here's the parallelogram family tree. This is in a Venn diagram. So a rectangle has 4 right angles, and notice how a square is in that orange circle. So a square is also a rectangle. Square is under a rhombus, and rhombus is in the blue. And a rhombus just has to have 4 congruent sides. And then everything within this picture is a parallelogram. So that's using a Venn diagram. If you want to do a hierarchy, here's what you have. If it's a parallelogram, then it can either be a rectangle or a rhombus, or neither. And if it's a rectangle and a rhombus, then it's considered to be a square. You'll need to know this hierarchy for the final. So here are some theorems. Theorem 613. In a rhombus, the diagonals are perpendicular. So a diagonal cuts from vertice to vertice, vertice to vertice, so AC is perpendicular to BD. Theorem 614. In a rhombus, the diagonals bisect a pair of opposite angles. So a diagonal is AC, and it bisects such that angle 1 and 2 are congruent, 6 and 5 are congruent. Diagonal BD bisects the angles, so 7 and 8 are congruent, 3 and 4 are congruent. What does this tell us about a square? Well, if it's a rhombus, it could be a square. So if it's a square, it has to be a rhombus. So these theorems are for rhombuses, so they also must be true for squares. So in my hierarchy, a square is everything above. A square is a rectangle, a square is a rhombus, a square is a parallelogram. But if I go down my hierarchy, a parallelogram could be a rectangle, or it could be a rhombus, or it could be neither. Find the measures of the numbered angles in each rhombus. So we know this is a rhombus, so we know our diagonals are perpendicular, but I only see one diagonal drawn. And the other theorem says that in a rhombus, the diagonals bisect a pair of opposite angles. So here's a diagonal, so that means this splits the angle in half, this splits the angle in half. So here are some things that happen because of that. So if this angle is 38, we know that this angle is also 38. And we're told that this is a rhombus. By the definition of rhombus, all of the sides have to be the same. So if I highlight part of my picture, I end up with a triangle, specifically an isosceles triangle, which means our base angles are the same. So I'm going to say that angle 1 is also 38. The same thing is going to happen in the bottom triangle. It is isosceles, so this missing angle would be 38. So for our yellow triangle, these two 38 degrees make up 76 degrees, and a triangle is 180. So if I subtract, I'm left with 104, excuse me. So that angle will be 104. And angle 3 would have to be the same because these triangles would be congruent, because by reflexive, their diagonal is the same by ASA. So angle 3 is also 104 degrees. Try number 6. Please pause the video while you work. So again, remember, a diagonal bisects opposite angles. So 1 and 2 would be congruent, 3 and 4 would be congruent. So I get some isosceles triangles because of the definition of a rhombus, all the sides would be the same. So I have a triangle with 73, 2, and 4. So I'm going to do 180 minus 73 is 107. So I have to divide that 107 into 2 equal parts. So I get 53.5. So 2 and 4 are going to be 53.5. Then these two triangles are going to be congruent because, again, angle, side, angle. So then all of these angles should be 53.5. What are the measures of the numbered angles in rhombus ABCD? So again, we know that the diagonals bisect the angle, and they also are perpendicular. So this was a slide that said rhombuses have diagonals that are perpendicular, so they meet at 90-degree angles. So that means that angle 1 is going to be 90 degrees. So then if this is 58, this angle is also 58. And remember, definition of rhombus is going to give us all sides the same. So then this yellow triangle would be congruent to this other triangle that I did not color. So this big angle is 58 times 2, which is going to be congruent to 2 plus 3. And remember that this is an angle bisector, so 2 and 3 are also going to be 58. So So if I just redraw this triangle on the bottom, so I am redrawing the pink triangle. I know that this angle is 90, angle 3 is 58, so that pink triangle has to add up to 180, so my missing angle is going to be 32. 180 minus 90 minus 58. Rectangle. In a rectangle, the diagonals are congruent, so they are of equal length. So in our picture, AC is congruent to BD. So if this is true for a rectangle, this is also going to be true for a square. Diagonals are congruent. So here is the question. QRST is a rectangle. Find the value of x and the length of each diagonal. So I went through and I sketched this rectangle knowing that Q had to connect to R, R to S, S to T. So this is what I came up with. So I'm going to label QS is a diagonal. So that's this piece. And RT is a diagonal, which is this piece. So because this is a rectangle, we just learned that rectangles have congruent diagonals. So I'm going to say that the red is equal to the purple. So 4x minus 7 equals 2x plus 11. And now I'm going to solve. Get my letters together, subtract 2x, add 7, divide by 2. So I have found the value of x. Then it says find the length of each diagonal. Well, they are the same, so I only have to find it once. So I'm going to plug it in for the red. So 4 times 9 minus 7 is 29. So QS is 29 and RT is 29. Please pause the video and try the next question below. So again, we know the diagonals are congruent. So we get 6x minus 3 is equal to 4x plus 19. Subtract 4x. Add 3. Divide by 2. So x is 11, and then if I plug in, I get 63 is equal to QS and RT. Please try the next 3 multiple choice questions on your own. When you're ready to see the solutions, turn the video back on. Here are the answers. In the rectangle, what is the length of the diagonal? Well, we know that diagonals are congruent, so we set them equal to each other, so we get x is 9. They want the diagonal. They don't want to know what x is. So I need to plug 9 in, and we should be getting the answer 33. On the next slide, which ones have diagonals that bisect each other? So I can look at the definitions of rectangle, rhombus, and square, but I think that shows up in our tests for a parallelogram. The diagonals bisect. So if it works for a parallelogram, it has to work for everything underneath. So I would say that this is going to work for all of these. Where are the angles going to be right? Well, I think we need to look at the definition. A rectangle has 4 right angles, so I think it's got to be a rectangle. And a square says it has 4 right angles, so it's got to be a square. So I know that rectangle and square are going to be choices. Does a rhombus always have to have the same conditions as a square? No. Does a parallelogram? No. So I think our only answers are rectangle and square. This concludes my video for lesson 6-4.